Hello everyone. Let us start with a topic in HSC mathematics, that is regression, which is from mathematics part 2. Okay. Regression is the study of prediction. Okay. Regression is the study of prediction, or it is also called as estimation. Regression is the study of prediction or estimation. That is to find out something, provided some other thing is given to you. Okay, so we'll be working on certain problems which are uh, there in our syllabus, but then prior to that we need to have an understanding about some basic formulae in statistics as well as uh, regression. Okay, so the first formula is of mean. So mean, which is also called as the average, the formula is summation x upon n. This is called as summation. Don't call it as sigma, call it as summation. Okay, then variance of x. Variance of x, so there are two formulae: summation x square upon n minus x bar square, or variance of x is equal to summation of x minus x bar the whole square upon n. Now which formula to use, that certainly the the question in front of us will let us know. Okay, then this is called as variance of x. V of x is nothing but variance of x. Then we'll proceed with standard deviation. Standard deviation, which is sigma x. Okay, standard deviation, which is sigma x, and this is called as sigma. Okay, so standard deviation formula is standard deviation of x is equal to root of variance of x. Okay, so you need to know all this formula, right? Then the next set of formula list is as follows: covariance between x and y. Again, we are having two formulae for this: summation x into y upon n minus x bar y bar, or covariance between x and y is equal to summation x minus x bar y minus y bar upon n. Which formula to use, that certainly will be uh, predicted from the given data in the problem. Fine. Okay, so the next series of formulae are from regression. So there are two lines in regression: line x on y. So this is line x on y. Okay, it's a line of regression where the variables are x and y. So here I'll just write x depends on y. X depends on y. Okay, so whenever x is dependent on y, x is the dependent variable. That means whenever we don't know the value of x, but then we know the value of y, so x depends on y. So we'll use line x on y. So there is an equation for this particular line, and that equation is x minus x bar bxy y minus y bar, bxy y minus y bar. So this is the equation of line x on y, right? Okay, so here x and y, we know what are x bar and y bar. X bar and y bar, they are the respective means of x and y. Okay, then we are having the regression coefficient. Regression coefficient of x on y. Now the regression coefficient of x on y is bxy. For bxy we are having two formulae: The first formula is covariance between x and y. Covariance formula I have already shared with you, upon standard deviation of y square, or bxy, which is the regression coefficient of x on y. This covariance is in terms of r sigma x upon sigma y, r sigma x upon sigma y. Now you might be wondering what is r. R was a part of our syllabus in class 11. Okay, so R is called as Carl Pearson's correlation coefficient. Carl Pearson's correlation coefficient. Fine. So Carl Pearson's correlation coefficient is R, right? Okay. It is also called as product moment correlation coefficient. Product moment correlation coefficient. Fine. So this particular slide is important when we are supposed to find out x from y, where x is dependent on y, x becomes a dependent variable, y becomes the independent variable, and we'll use this line of regression. The second line is line y on x. Here y depends on x, y becomes the dependent variable. The value of y is not known to us, but then the value of x is known. So we'll predict the value of y from x. So this line also has an equation. We'll just write down the equation for this line. Y minus y bar byx x minus x bar, x minus x bar. Okay, so this is the line, regression line of y on x. Fine. Then let us understand what is byx. Byx is nothing but a regression coefficient of y on x. Regression coefficient of y on x is byx, which is equal to, we are having two formulae over here: covariance between xy upon standard deviation of y square, or byx is equal to r sigma y upon sigma x. Okay, sigma y upon sigma x. Fine. Now r, as I said, it is Carl Pearson's correlation coefficient, and correlation is not the same as covariance. So these are two different things. Okay. The formula for r in regression is root of byx into bxy, root of byx into bxy, right? That is the formula for small r, and the value of r always lies between -1 and 1. You should remember this. Value of r always lies between -1 and 1. Fine. Okay, so we'll take some examples from the textbook. Okay, government textbook, Maharashtra State Board government textbook, and we'll solve these examples one by one. The problems given in the exercise are not in a very precise manner. Okay, the order, I mean, not the problems, but then the order of the problems. Okay, so what we can do is, you can follow the order in which I am solving over here, and hence you can revise in the same order. So what you can do is go to exercise 3.1, which is in government textbook. Okay, and we are having question number 3 over there. You can refer the question from the textbook. You can refer the question from the textbook, exercise 3.1, question number 3. Okay, so there are 5 pairs of observations. So I'll write down the given data. So n is equal to 5 pairs of observations. Summation x and summation y is already given to us. Summation x and summation y is already given to us. Okay, summation x is equal to 20. Summation y is also equal to 20. summation x square is equal to 90, summation y square is equal to 90, and summation xy is equal to 76. What we'll do is we'll calculate the means x bar and y bar, because means are always required in the problem. Summation x and summation y, which is equal to 20 upon 5, which is 4, and y bar is also equal to 4. 20 upon 5, which is equal to 4. So we have calculated the values of x bar and y bar. They have not asked directly what is x bar and y bar, but then it is always good for us to keep this numbers ready in front of us. Okay, so this was the given part. First thing what we are supposed to calculate is covariance between x and y. Covariance between x and y. We have two formulas. I'll show you the formula. Covariance between x and y. Okay, but then they have given us this data. Summation of xy they have given. The total of xy is given to us. So we cannot use the second formula. We'll have to use the first formula itself. Fine. So summation xy upon n minus x bar y bar. Summation xy upon n minus x bar y bar. Now summation xy is given as 76, n is given as 5, and x bar y bar we have calculated 4 into 4. So 76 by 5 minus 16, which is equal to 76. Take LCM, this will go over here. 5 into 16 will be 80 upon 5, which is equal to minus 4 by 5. Okay, so we got the first answer as minus 4 by 5. Now they are asking covariance, and we have got the covariance. Okay, now this is not a very difficult fraction to divide. So if it is not a very difficult fraction to divide, you can just divide it and present it to the paper corrector. Okay, something like 3 upon 19, or maybe even 21 upon 37. Now these are difficult fractions, so you can keep it as it, but then easy fractions you can just divide. Okay, so the first part of the problem is over. We have calculated the covariance between x and y. Then byx will, I'll show you the formula for byx. First formula in the second formula. See, now covariance we have already calculated, so it's good for us to stick to that formula of covariance, the first formula. But then standard deviation of y square, that we don't have. So first we'll have to calculate standard deviation of y. Okay, so look at the method. We'll just write the formula first. Covariance between x, y upon standard deviation of x square. Byx. I think I made a mistake over here. It should be standard deviation of x square. Fine. Okay. And then okay, let this be equation number 1. I hope you made the correction over here. It has to be standard deviation of x square. Fine. Yeah. So variance of x first we'll calculate. First we'll calculate variance of x. Again, for variance of x, we are having two formulas. The first formula and the second formula. Okay. The first formula is applicable over here because we are having this data, summation of x square. If you take a look at the question where the book is right there in front of you, summation of x square, this data we have. So we'll use this formula, the first formula, summation x square upon n minus x bar square. So summation x square, the data is given to you as 90 upon 5 minus x bar. What is x bar? X bar is 4, which we have calculated right at the beginning. 90 by 5 minus 16. Once again, we'll have to take the LCM. 16 into 5 is 80, and this is 5. So 10 upon 5, which is 2. So we got the variance of x as 2. Now, standard deviation of x. is equal to square root of variance of x, which is square root of 2. Okay. So what is standard deviation of x square? Standard deviation of x square, we'll have to square both the sides. Square this and this will be the standard deviation of x square. So that will be 2. Fine. So now we have both the values. We are having covariance as well as standard deviation of x square. We can just put these values in equation number 1 and get the answer for byx. So from 1, byx is equal to covariance of xy, that is minus 0.8, and this is 2, so this is minus 0.4, minus 0.4. Okay, right? So we got byx. Now we are interested in bxy. Bxy, again the same formula in terms of covariance, bxy upon standard deviation of y square, equation number 2. Now covariance of xy we have, which is the numerator. Denominator, we are having standard deviation of y square. Standard deviation of y square, we are supposed to calculate. So while calculating standard deviation of y square, we'll first calculate variance of y. Variance of y is equal to summation y square upon n minus y bar square. Okay, we are using the first formula for variance of y. We are using this formula because we are having summation of y square. Okay, so it all depends on the data which formula to apply. The summation of y square is 90 upon 5 minus 4 square. Now if you see, the calculation is exactly same as for variance of x, so you can directly write the answer as 2. If you calculate this, you are supposed to get 2. Okay, but then we are interested in standard deviation of y. So standard deviation of y is equal to square root of variance of y, which is square root of 2. So squaring both the sides, we'll have to square because the formula demands a square. Look at equation number 2, which you have copied. Equation number 2 has a square, hence I have squared both the sides, and I've got the standard deviation of y square as 2. So from 2, bxy is equal to minus 0.8 upon 2, which is minus 0.4. So byx and bxy are exactly same. The answer is minus 0.4. Okay. Now the last part they are asking is r. Now before we calculate r, let me tell you something which is more important with regards to r. Okay. So here r is positive if and only if bxy, byx both are positive, and r is negative if and only if bxy, byx both are negative. So if both are negative, r is negative, final answer. And if both are positive, the final answer of r will be positive. I hope you are understanding this. Okay, so in our problem, what we'll do is we'll go ahead with the calculation of r, which is the third part of the problem. R is equal to root of byx into bxy, which is minus 0.4 into minus 0.4. Okay, so this will be 4 upon 10 into 4 upon 10, because see, minus into minus is plus, and 0.4 is written as 4 upon 10. So there is a square root, so out of this one pair, 4 will come outside, and out of this pair of 10, 10 will come outside, but then in the denominator. So r is equal to 0.4, but then I'm going to put a minus sign over here for r, and I'm going to write r is negative since both byx and bxy are negative. If both are positive, then r is also positive. I hope you are understanding this. So that was the solution for the first problem. Okay, exercise 3.1. This was from exercise 3.1, question number 3. Let us take some more examples, but then not from the same exercise. As I said you, the order of the given problems is not very correct in the textbook. So we'll follow our own order, right? So exercise 3.2, government textbook, exercise 3.2. Let's go to question number 1, right? Okay. I hope you are right there with your textbook. Okay, so we are on exercise 3.2, question number 1. I hope you're taking a good look at the data which is given over there. X bar is equal to 53, y bar is equal to 28, byx is equal to minus 1.2, and bxy is equal to minus 0.3. So there are three parts in the problem. The first part, they are asking correlation coefficient. Correlation coefficient is nothing but Carl Pearson's correlation coefficient, which is small r. It is also called as product moment correlation coefficient. Okay. So the first part of the problem is small r. Small r is equal to byx into bxy under root. So minus 1.2 into minus 0.3. Okay. Which is equal to this negative into this negative will be positive. It will be positive. Okay, and this will be 12 upon 10 into 3 upon 10. So this will be 36 upon 100, and if you know 36 upon 100, 36 and 100 both are perfect squares, so the root will be 6 upon 10. So r will be written as minus 0.6. The answer is 6 upon 10, which is 0.6. But then why we are taking this r as negative? R is negative because r is negative since byx and bxy are negative. We need to mention the reason to the paper corrector. Okay, r is negative since byx and bxy both are negative. So the first part of the problem is over. So we'll focus on the second part of the problem, right? So second part of the problem, we are interested to find out the value of y. Estimate y means we are supposed to find out the value of y. We are supposed to predict the value of y when x is equal to 50. Now, y value is unknown. Y value is unknown. Whenever the value of y is unknown, it becomes the dependent variable. Any value which is unknown, it becomes a dependent variable. So y is the dependent variable. X is the independent variable. So y depends on x. We'll write this information. Y depends on x. Why y depends on x? Because the value of y is unknown. So use line y on x. Okay. So y minus y bar byx into x minus x bar. Okay, now see, look at the problem, look at the given data. We are having y bar, we are having byx, and we are having x bar. Okay, and we also have x as 50. So all these colored values we are having, right? Y minus y bar. What is y bar? Y bar is 28. Byx is equal to minus 1.2. X is 50. X bar is 53. Okay, so we have to solve this further. Y minus 28 minus 1.2 into BODMAS says that the bracket has to be sorted first. So minus 3, 50 minus 53 will give you minus 3. So y minus 28 is equal to 3.6. Okay, minus into minus is plus. 1.2 into 3 is 3.6. Minus 28 will move on the next side, on the right hand side. Okay, so it will be 28 plus 3.6. Y is equal to 31.6. Y is equal to 31.6. Okay, so that's how we have predicted the value of y. Okay, right? So that was question number 2, as in sub question 2 from the first problem. We'll proceed with the next question. Sub question 3, we are supposed to find out the value of x when the value of y is equal to 25. So y value is known to us, x value is unknown. So if x value is unknown, x becomes the dependent variable. X is dependent on y because its value is unknown. So x depends on y. So when x depends on y, okay, use line x on y. Use line x on y. Okay. If you just revise the formula, okay, then line x on y is x minus x bar bxy y minus y bar. Okay. Now x bar, y bar, bxy, these values we have. Okay, and the value of y is also present in the problem as 25. So all these colored values we have. So x minus x bar, what is x bar? X bar is equal to 53. bxy is minus 0.3. Y minus y bar, what is y is y is 25, as we can see. Okay, and y bar is 28. So x minus 53 minus 0.3 into minus 3. Fine. So minus 0.3 into minus 3 will give me 0.9, because minus into minus is plus. So x is equal to 53 plus 0.9. X is equal to 53.9. So that is how we have calculated the value of x. Okay. Fine. Then let us proceed with exercise 3.1, question number 9. Okay. Question number 9, 3.1. Okay, easier problems we'll do first. We are supposed to find out the value of x, okay, when y is equal to 10. We are supposed to find out the value of x when the value of y is 10. Okay. Now see, x depends on y because the value of x is not known to us. So x depends on y. Okay. So use line. We are supposed to use line x on y. Okay. So x minus x bar bxy y minus y1. Let us make this as equation number 1. We know the value of y. The value of y is 10. Okay. X bar y bar values also we know. Okay. But then bxy value we need to calculate. Bxy value we need to calculate. Fine. So bxy is the regression coefficient of x on y. So there are two formulae for bxy. Okay. Formula number 1 and formula number 2. So this time we are going to select formula number 2 because in this particular question, in the question number 9, exercise 3.2 of your government textbook, okay, they have given the value of r. R value is given to us. So whenever r value is given to us, we'll have to use the second formula, not the first one. Okay. So bxy is equal to r sigma x upon sigma y. And if you take a look at the problem, all these three values are given to you in the problem. All these three values are given to you in the problem. So that should not be a problem for you. Okay. So what is r? R is equal to 0.7. I'm writing it as 7 upon 10. R is 0.7 given to you. I've written it as 7 upon 10. Sigma x is 3.2 and sigma y is 16. So 7 upon 10 into 32 upon 10. 3.2 I have written as 32 upon 10. And this 16 I have written as 1 upon 16 because 16 lies in the denominator. Okay. So 16 ones are 16 twos are. So this will be 14 upon 100. This will be 14 upon 100. Okay. Right. Now it's easy to for us to divide. So this will be 0.14. So we got the value of bxy as 0.14. So from equation number one, equation number one, now we also have the value of bxy. We also have the value of bxy. So x minus x bar value is given in the problem. Bxy we just calculated 0.14. Okay. Y value is 10. 10 minus y bar. What is y bar? Y bar is 14.8, which is given in the problem. Okay. So x minus 7.6, 0.14 into 10 minus 14.8 is minus 4.8. Okay. Minus 4.8. Okay. So 0.14 into 4.8. That calculation you need to do. Okay. Be very clear in your calculations. Okay. So 0.14 into 4.8 manually you need to calculate. So this will be negative 0.672. Okay. Negative sign is due to this sign. Okay. Okay. So x minus 7.6 is equal to negative 0.672. So x is equal to x is equal to what you have to do is you'll have to take this minus 7.6 on the right hand side. 7.6 minus 0.672. 7.6 minus 0.672. So this is the 7.600 minus 0.672. Okay. You'll have to subtract this in this way. 6.928 is the answer. Okay. So the value of x is 6.928. So this was just an introduction part of the chapter. We'll work on many problems in this chapter so that your topic for the board exams is clear. Okay. Thank you.